All right, so we should be on this page here at the top. It says arc, measure, and central angles. So yesterday when we went over all those vocab words, we talked about what an arc is and the different ways to classify arcs. We talked about minor arcs, major arcs, and semicircles. Today we're going to continue to talk about those arcs, but actually start to find measurements on a circle and want to know how much an arc might possibly be. Now, there is a difference, and we'll see this later in our unit as well. There's a difference between arc measure and arc length. Yesterday, when I talked about arcs and like how it's a piece of their circumference, I gave the example of like if you had a piece of pizza and you took a couple of slices from it, your crust by itself would be a part of the entire circumference from that full pizza. Now, when I talked about that, I could actually measure my crust two different ways. I could measure it in terms of an angle, like degrees, or I could measure it in terms of like centimeters or inches. However, maybe I was going to choose to measure the crust in like a unit. So when they talk about arc measure, they're talking about how much it is in like a degree or how many angle degrees it would be. Or you're talking about arc length, which is when you're getting into like centimeters and inches instead. Okay, and we did talk a little bit about arc length when we went over the unit where we went over just like perimeter and circumference and area formulas. We had a whole unit on just circles, like a whole day, and we did talk about arc length in that. So I just want to clarify that's a little bit of a difference here. Is today we're not talking so much about what it is in centimeters or inches. We're talking about how much it would be in degrees. Now, yesterday we also talked about how many degrees are in a full circle. Anyone remember? Good. 360 degrees makes up an entire circle. Now, let's refresh our memory on our arcs that we talked about yesterday. We had three types. We had minor arcs, major arcs, and a semicircle. What did we say in our notes yesterday a minor arc has to do? Less than 180. So I'm just going to write this at the top. A major arc had to, good, greater than 180. And a semicircle? It equals 180. Good. So keep that in mind today as we start to work with the measurements. When we're given a name of an arc, we want to make sure that it makes sense with what type we're thinking it's going to be. We also talked yesterday that minor arcs have 2 letters, major arcs have 3 letters. Semicircle can kind of go either way. Most of the time today, when you're working with a circle, unless you're dealing with the diameter, which you might from time to time, but usually they're going to be focusing on either major or minor arcs. Make sure that you can tell, like, how many letters are they using to name the arc? Because that will tell you a little bit about how much should it be. You know, if I'm dealing with a minor arc, I shouldn't be writing down an answer of 200 because that doesn't make sense with what we said our definition of a minor arc does. Okay? Now, inside of a circle, if we look at this first one, there's also some terminology up above where it talked about arc measure. It said that in a circle, the degree measure of an arc is equal to the measure of the central angle that intercepts the arc. So let's talk about what that all means. In my picture here, notice how they kind of drew in this angle on the inside. Could someone go shut the door for me? So on the inside there where B is at, that's the center of your circle. That's a central angle that was drawn in. Okay, so this piece right here is called the central angle. So I don't know if you want to maybe label that in your guys' notes just so you kind of know what they're talking about from up above. But this piece here would be known as the central angle. Which kind of makes sense because it's an angle from the center of the circle. So it kind of fits its name. Now down below where A and C are at on the outer edge of the circle here, this would be the arc. Okay, so like A to C would be the arc that we're talking about. And up above it said that the central angle intercepts the arc. Well, if you think about intercept, like what that means in other terms of like other areas in life that we talk about things being intercepted. It basically means that like you kind of step in and you're taking it from somebody. Okay. So when we're talking about an intercepted arc, the angle is kind of coming in and grabbing that arc and containing it to itself. So these lines, BA and BC, those segments, those are the sides of my angle here. And then notice how the endpoints of those angles are the endpoints of the arc. So that's why they're going to say it intercepts that arc. It kind of grabs it and kind of holds on to it. Now what they're saying up above is that the measurement here between the central angle and the arc are going to match. They're going to be congruent. So if I know that this angle B is, let's say, 55 degrees, then that means this arc out here is also 55 degrees. And again, we also said a little bit ago that an entire circle, so if I were to connect this and go all the way around that center point, that this would be 360 degrees total if I go all the way around the circle. Now, if I wanted to just figure out how much the other side of the circle is, I would take 360 minus that 55, and that would give me the other side of the circle. As we go into some examples later today, you'll see them label either arcs or central angles. They may not be exclusively only labeling arcs. They may only give you central angles, or they may mix and match. And they throw in a central angle in one place and then throw arc measurement in somewhere else. You might have to go back and forth between them. So it's important for you guys to know that they're going to be equal. Whatever that central angle is and the arc that it intercepts directly underneath it is going to be equivalent. The other circle that we have over here is just to remind you that when we're dealing with a semicircle, that means there needs to be a diameter present in the picture. So remember, diameter from yesterday, it goes through the center and connects edge to edge of the circle. And if that happens, it splits that circle directly in half. Well, if a full circle is 360 degrees, then half a circle would be 180. If you see a diameter in the circle, or if they tell you about the picture, they give you some description and they mention a diameter is occurring, you can use that information then to maybe help you find angles. Because if you know like the whole side is 180 and then they're kind of cutting it into smaller parts, and maybe you know some of them, or they give you some information about how they relate to each other, you could then figure out how much they are. Okay, so we're going to get into some examples now where we actually solve for arc measurement, or we solve for an angle, like a central angle in here. Now, they might give you some information in the picture, like this one over on the left there says, given circle B with EC as a diameter. So we know that that line segment EC is going to split the circle directly in half. Okay, so let's just keep that in mind as we're working with this. Then you'll notice underneath there's 4 parts. The first 3 are wanting you to find measurements of arcs. I see those letters with like the little arc on top, so that's why I know it's an arc measurement there. And then the last one is just talking about an angle. So we're going back to talking about our central angle. What I honestly like to do is I like to ignore everything on the left for right now, and I'm just going to zoom in on my picture, and I want to fill in anything that I can. I want to fill in any angles or any arc measurements that I can here. Now they're giving us some information, so let's use what we just talked about. Central angles and their arc measurement are the same. So this central angle here is 39 degrees, which means that this arc that it intercepts, AC, should also be 39 degrees. So I'm going to go ahead and label this as 39. What else do we know in our picture? K to D is also 39, and we know that because why? Yeah, those markings. So I'm going to mark the measurement of the arc, and I'm going to do the angle too. I like to have both because we saw over on the left, sometimes they want the arc, sometimes they want the angle. So it's nice just to have it all filled in. What else do we know? And how'd you get that?
Because E to C is 180, so 180 subtracted by 39 is 141.
Good. Okay, what he said there is he knows that diameter's in there, so that's 180 from E to C. He just took away the 39 from the 180 to get that 141. Great. What else do you guys know? Can we use this for anything? A arc is 71. Okay, tell me how you got the 71. 39 plus 70 minus 180. Yeah, we're dealing with the other half of the diameter, okay? Because if E to C going like clockwise is a diameter, E going to C counterclockwise is also a diameter. And so you knew that this was 70 here, this is 39, so we just subtract those from 180. If I know this is 70, can I label this with something? What is it? 70. So go ahead and just fill that in too. Okay, I think we've got everything labeled. So now I'm going to kind of zoom back out. We're going to come back over here. And let's figure out how much these are. Now, you're going to want to be careful when you're looking at an arc and that you go the right direction. And we talked a little bit about this already today. But remember, a minor arc is going to be named with 2 letters. So it should be less than 180. A major arc is going to have 3 letters. Diameters can do both. So if they talk at all about E and C, we would want to maybe check, are they talking about the diameter there? Okay, but when I see 2 letters, most of the time my initial response is to think it's going to be a minor arc, so it should be less than 180. The issue though that I see kids make is they don't know what direction to go. They maybe know where to start, but how do you know if you should go like clockwise or counterclockwise around the circle? It depends on the arc that you're working with. You need to go in the direction that makes sense with what kind of arc you think you're dealing with. So for example, on this first one, AC. AC has 2 letters. That means it's a minor arc. It should not be greater than 180. So if I'm looking at my picture, A is here and C is here. So I have 2 choices. I can either go A to C clockwise and get 39, or I could go A to C counterclockwise and get whatever 360 minus 39 would be. Which one makes more sense though if this is a minor arc?
Just go from A to C.
To go this way, right? Because it's less than 180. But I see that happen all the time. Kids get really confused on what direction I'm supposed to go around the circle, especially if they're maybe farther apart. Like A may be going to K. How do you know which way you're supposed to go? Well, look at the name. The name's going to help you know if it should be bigger or smaller than 180. Since this is a minor, I'm just going to go clockwise A to C and say that it's 39 degrees. Okay, next one, A to E. Which direction from A should I go to E? Should I go to the left or should I go to the right? Counterclockwise or clockwise? Counterclockwise, because again, we have 2 letters. It's a minor arc. It's got to be less than 180. This is going to be more than 180 because it's already got the semicircle in here, plus 39 more. So how much is A to E going that way? 141. Okay, what about E to K? 71. Good. And the last one, it's not an arc anymore. It's talking about a central angle. So trace the angle if you need to. Make sure that you're going from K up to B, the center, and then back down to D. How much is that? Good, 39. Questions on that first one? Okay, I want you guys to look at the second one here. I'm going to let you guys try this one on your own, but there is one thing that I would maybe suggest that you add. Back up on this one, they had all the lines from the center connecting to those points on the edge of the circle. Do they do that for this one? No, but you can draw them in. There's no rule saying that you can't do that. So I'm going to go ahead from my center A, I'm going to connect to H, K, E, and D so I can kind of see the slices of my circle here. And then I'm going to give you guys a couple minutes to try to do what you can with this one. Okay, if you're getting close to being done, you want to maybe compare with the people at your table, see if you guys all got the same measurements. Okay, so let's go ahead and start filling in. I just want information from the circle first, and then we'll go over and start filling in what they actually asked for. So when you first looked at this circle, where'd you start? What'd you start filling in? 53 can go on the inside, and the 34 can do the same thing, right? Okay, so that gets us a good start. What'd you guys do next?
The bottom half is 60s.
Why are all of these 60s? Can you explain how you got there?
180 divided by 3.
Yeah, and you know it's 180 because what's showing up in the circle? The diameter. F to C is a line that goes across the circle, like edge to edge, and it hits the center, which means it has to be a diameter. So that's 180 divided by 3, like she said. So yes, I agree. These are all 60 degrees. All the arcs are 60, and all the angles are 60 too. Okay. What about the last one up there? What do you want to do?
Add 34 and 53 minus 7.
Okay. So 34 plus 53, and then we would subtract that from 180 because we're working with the other half of the diameter. And you got what? 93. You could also, if you wanted to, some maybe think this way. If you know everything but that, you know all the circle but this, you could take 360 minus all of these angles if you wanted to. That might be a little bit more math that you have to do, more adding and then subtracting that number there. Okay, I think we've got everything filled in. So now we should be good to answer our questions over here. Okay, so starting with arc CE. Is CE a major arc or a minor arc? Minor, because it has 2 letters. So it's got to be less than 180. So C to E is how much? 87. Very good. Because you have to go from C, I'll just highlight here, from C to E. You have to go this way. You don't want to go the other direction to connect it because that's going to be over 180 and it doesn't make sense. But students will do that. I see that mistake all the time. They go the wrong way. So make sure you're looking at how are they naming the arc. That tells you what your measurement should be. That should help you know what direction you're supposed to go. Okay, what about EF? 93, everyone agree? Okay, that's another minor arc. Okay, next one, ECK. What kind of arc are we working with now? Major, because it's got 3 letters. I think kind of the major arcs are easier because you can follow the path of the letters. So it's a little bit easier to know what direction you're supposed to go. I start at E, which is here. I have to go towards C, okay? And I don't want to go this way because I would bypass K. I don't want to hit the other letter that I need to get to. So I want to go E to C this way and then to K. How much is that? 207. You're just going to add 34, 53, 60, and 60. That's how we get that 207. Okay, what about the last one, DFC?
307.
Good, 307. Okay, DFC. Again, you want to go from D towards F, but you don't want to hit your C. So that's going to tell you start at D, you go this way around the circle. It's everything but the 53. So take 360 minus 53, you get 307. Do we have any questions on that? Okay, I am going to give you your homework, but there's one thing you're going to see on your homework today that I want to talk about really quick. So I'm going to pull that up here. Do you guys, does anyone in here know or have you heard the term concentric circles? Anyone ever heard that? Okay. Have any of you ever played like darts? Or you know what a dartboard looks like, or like a target in like archery or something? Okay. Concentric circles means they're circles inside of each other. So on your homework, you're going to see problems like this one here. This is considered a concentric circle. This circle is inside of the bigger one. Okay? What that means as far as what we've been talking about today is that your angle measurement, like here, so I'm not going to do the math, but I don't know how much this one is, but let's just pretend like this was, I don't know, 113 degrees. Okay? If this is 113 here, then this arc H to E would also be 113. And this big arc C to D would also be 113. The reason why they all match is because they're similar circles. So a dilation occurred, so everything has either increased or decreased proportionally. That does not impact the overall angle measurement that you're going to have on your shape. Maybe the arc length, like how many centimeters they would be, would change proportionally, but the degrees will not. So I just want you to know that like this central angle here, this arc here, and this arc here are all going to be the same measurement. That goes for any picture that you see that deal with concentric circles. I wanted to talk about that though because we've never seen that in this class before, and we haven't talked about that. We didn't talk about that today. So you'll have some of those. I wanted to give you a little bit of a warning so that when you see it on your homework, you're not confused on what to do. Questions on that? Okay.